Today we're doing a continuation from the lesson before. So again, we're using properties about unit circle. We discussed the reciprocal identities and we discussed the quotient identity. So you should have that written in your notes already. So the first example says given that sine of theta is equal to 2 over 5. That's a 2 up there. And cosine of theta is equal to the square root of 21 over 5. Finds the remaining functions. So they have given you 2 of the 6 functions, and they want you to find the rest of the 4. So we're going to kind of make our list out. We know sine, we know cosine. First thing we can use is the quotient identity to find what tangent is. And tangent of theta, quotient identity says if I know the sine value and I know the cosine value, I divide those two values. So the sine value is 2 over 5. Cosine value is root 21 over 5. And we know we can't leave a fraction divided by a fraction, so we have to keep change flip. So I have 2 over 5 times 5 over root 21. Notice I have a 5 in the top and the bottom, so they're going to cancel. So now I'm at 2 over root 21. And now we rationalize, and by now you should know that shortcut that the square root essentially moves up and it drops in the bottom. So 2 over root 21 over 21 is our tangent value. So we know sine, we know cosine, we found tangent. Reciprocal identities are also the easiest to use. So if sine is 2 over 5, the reciprocal of that says it would be 5/2. So that's cosecant. Secant of theta is the reciprocal of cosine. So I take my cosine value and I flip that. So I have 5 over root 21. Again, we rationalize, and that just means I multiply top and bottom by root 21. So I get 5 root 21 over the square root of 21. Sorry, not square root, just regular 21. And the last one I need to find is cotangent. So a couple ways to go about finding cotangent. I know cotangent is cosine over sine, but I also know that cotangent is the reciprocal of tangent. Now, if I go to this answer right here, let me change my color. If I go to the answer right here and I flip this one, notice after flipping it, I will now have a square root in the bottom, and that means I have to rationalize all over again. So instead of taking the reciprocal of this answer here, we're going to go back a step, and I'm going to take the reciprocal of that fraction right there, so that way when I flip it, there is no more square root in the bottom. So cotangent is root 21 over 2. Would you have gotten the right answer if you used this one? Absolutely. It's just you would have had to rationalize. So that is an example of when you're given 2, you find the remaining. So let's try another one. Okay, so you're given that sine of theta is equal to 1, and you're given that cosine of theta is equal to 0. And they want you to find the remaining trig functions. So setting it up, I know sine is 1, and I know cosine is 0. So to find tangent, I take my sine value divided by cosine. So I do 1 divided by 0. 1 divided by 0, nothing can be divided by 0, so that means this answer is undefined. Cosecant is the reciprocal of sine. So if I go back over here, any number can be written over 1. If it doesn't appear as a fraction, you can make it look like a fraction. So sine is 1, which came from a 1 over 1, so cosecant is still going to be 1. Secant, however, So 0 over 1 is 0. Notice 1 over 0 is undefined. It's the placement of the 0. So when I take the reciprocal of the 0 over 1, I get 1 over 0, which is undefined. And lastly, cotangent. Cotangent was undefined, and undefined came from 1 over 0. So when I take the reciprocal of that, I get 0 over 1, which is just 0. So quick little mental note that the reciprocal of undefined is 0, and the reciprocal of 0 is undefined. The last thing I would like to do today is give you the final set of identities, and that's the Pythagorean identities. So these are your Pythagorean identities. And again, these are something you have to memorize. You need to know them and need to know how to use them. So there's 3 of them. The first one is sine squared of theta. Notice it's the function that's squared, not the angle. Plus cosine squared of theta equals 1. The next one is 1 plus tangent squared of theta is equal to secant squared of theta. And lastly, 1 plus cotangent squared is equal to cosecant squared. So these are your 3 identities, and we're going to use these now to find missing trig functions. So now, last set of examples I gave you 2 functions and you found the rest. Now I can give you just 1 function and you're able to find the rest of them. So for an example on this, the directions say, given sine of theta is equal to 3 over 5, find the value of cosine. Now again, I could say find the value of all 6. If you have 1, you can use the Pythagorean identities, and then you're able to figure out the rest of them. We're just going to practice with finding 1. So notice you're given sine. So when you look at those lists of identities, you need to pick the one that has sine in it, and that would be my sine squared plus cosine squared equaling to 1. So my sine value is 3 over 5, that quantity squared, plus cosine squared equals 1. So when I square a fraction, it's like writing it out twice and multiplying it together, or you can think of it as squaring the top, squaring the bottom. So it's 9 over 25 plus cosine squared. Now, instead of 1, I want to start getting that common denominator. So if I go back a step, I know this is like a 1 over 1. And I need a denominator of 25. So this is a 25 over 25. Notice 25 divided by 25 is 1. So I have not changed the problem. I simply rewritten it. So I have common denominators. That aspect of the problem will be different for every example that you do. It depends on what the denominator of the fraction is. To get cosine by itself, I'm going to subtract this 9 over 25 from both sides. So now I'm at cosine squared equals 16 over 25. To get cosine by itself, I take the square root. So cosine of theta is equal to 4 over 5, because I took the square root at the top and I took the square root at the bottom. So let's try another one like that. Okay, so given that cosine is 1/2, find sine. So notice now you're given cosine, but you can still find sine. It works very similar. So sine squared of theta plus 1/2 squared, because 1/2 is the cosine, so I'm replacing cosine with a half, equals 1. Now I square that fraction. So 1/2 times 1/2 would be 1/4. And instead of writing 1, I want to change it so I have common denominator. So I'm going to change this 1 over 1 to be 4 over 4. So again, notice that part changes every time. It depends what the bottom of the fraction is. Subtract this 1/4 over. So sine squared of theta equals 3 over 4. And now I squared the sine to get it by itself. Cannot take the square root of 3, so the top remains the square root of 3. I can take the square root of 4, so that becomes 2. And this would be your answer for sine. Now, if I change the direction and said find the remaining functions. Now that I found sine, I am able to find tangent, which means I can find cotangent, and I can find the reciprocals of these two. So you can build off of these. So that's all for today.